Good afternoon, everybody. Today, we're going to talk about problem number 2, problem setting for the USACO 2023 February contest Platinum level. This problem is like this. So you have Farmer John created n problems. So n is up to 10 to the power 5, and recruit m test solvers. N is 1 to 20. And then each problem solver rates the problem easy or hard. So for example, in this case, you have one problem solver, 3 problems. So it says easy, hard, hard. Then his goal is to create a problem set picking from those 3 problems. And you can pick 1, you can pick 2, or you can pick 3. But any problem in the front has to be easier than the problem, easier or same as the problem behind it. So no problem set, no problem solver can think the problem in the front is harder than the problem in the back. So in this case, you can have all those, for example, all those combinations, right? So you can pick this one, you can pick this one, right? You can pick 1 and 3, or you can pick 3 and 1, or you can pick 1, 2, or 3, 2, right? Or you can pick 1, 3, 2, or 3, 1, 2. Right? So how do we solve this? Immediately, we see m is less equal 20. What does that tell you? That tells you it is a bitmask, right? So you can have combination up to 2 to the power of m. Okay, so if we look at problem like this, if we look at here is your problems, and here are your solvers, right? So each solver can rate the problem hard or not hard, right? So for example, if you have 4 of them, so if I take this as my bitmask, right, then I will have 2 to the power of m, that's m solvers, right? That's m solvers. There's 2 to the power of m possibilities for this bitmask, right? So we can, problem like this, we usually can do it by dp, right? So if I define my dp as the number of ways to create a problem set, so that the last problem, right, the last problem is the bn I have here, right? Last problem is my bn. So I need to figure out, to do dp, I need to figure out how to derive from a previous state to this state, right? The problem, as we said here, if you have problems, the problem in the front, right? In this, for example, in this case, easy, hard, you can do this, right? So if I have easy, hard, problem in the front, if you have a set of problems, let's say it's problem 1, problem 2, up to problem k, the problem in the front has to be easier than the problem in the back. So basically what you mean is, if you look at the two consecutive ones, if they're both easy, that's okay. If easy is hard, that is okay. If hard, is okay. What's not okay is this, right? So this one's not okay. This is okay. This is okay. This is okay. You cannot be hard first and easy later. So that means if you look at the relationship between those two, pi plus 1, if you AND those, right, has to be P of I, right? So has to be in the front. So with that, then so that applies if you have this BM, right? BM and bit mask of I plus 1 has to be bit mask of I, right? Then if you look at the dp of BM, okay, you can be either problems are the same, right? So it's the same, or you can take all the BM, all the, let's call it the BM prime, take all the BM primes, that BM prime is not equal BM, and the BM prime and BM equals BM prime, right? You can take all of those possible ones, right? You can either is the same of this, or you can take the one that is satisfy this condition, okay? So then for the ones that are BMs, how many, you could have multiple of this, right? So let's say number of sets, okay? Let's say number of problems of this, which is BM, let's call it count. Let's call it count of BM. That can be easily calculated, right? So if that is, let's call it as a frequency, okay? Then how many different combinations you can have? This is, you have to do a combination, okay? So how many combinations you can have? You can pick one, right? If you have this, you can pick one of them. So it's, let's call it F1. So it's easy to write. You can do it, you can just pick one of them, or you can pick two of them. So that is F1 minus 1, right? Or you can pick three of them. So the first one you can pick from F1, second is, third one you can as 2, right? So on and so forth, right? So that's a easy calculation, right? So if you, so that's our, so that is the combination, right? So that combination can be easily, if you take the AP stats, right? So you know that is I from 0 to x exponential to I exponential and factorial minus 1, right? So I don't have 1 plus in the front. Okay, and that, if you guys remember, that is a simple calculation, right? So that is, combination of f1, right, or x is can be calculated as, you can return 1 plus, if f1 equals 0, then you give you a 0. Otherwise, you can give you combination of f1 minus 1, right? So that's easy calculation, right? So basically it's from AP stats. So under this count, you can calculate it easily, right? So remember you can create this, you just need to create it once, right? Because you do from, you do I, right? You can do I from 1 to n, right? Then you do j from 1 to n, right? So I from 1 to n, j from 1 to n, you calculate that bit mask, then you calculate that bit mask then you count of that bitmask plus, right? So that is, you calculate it once. Okay. So that is complexity, right? So it should be fine because it's 20 times 203. Okay, so now let's look at what's the complexity here. It will be, this complex is n, and this one you have to go through all the combinations, right? So that is O plus 2 to the power of n. Yeah, actually it's 3 to the power of n, right? So that may be okay, or maybe a little bit too big. So let's reduce 3 to the power of n. Okay, let's see, can we reduce it from, only reduce this from, I mean, this you cannot do anything about it. And this, can I reduce it to 2 to the power of n times something? Okay, how do I do that? So let's look at this one more time. Every time I have to calculate sum over all the bn's, right? I have to sum over all the bn's. If I do it, if you look at, if I add one, so sum of all the bn is 2 to the power of n, right? Can I put this as a linear, let's say n. So if we do this, if I say dp, let's say dp2 is my bn, but let's say have a second factor is I, which is when I do these two things, right? Bn prime and Bn, when I AND them, let's say the first I bits, okay, let's look at the first I bits. Let's say they different only in the first I bits. So after that, they're all the same. Let's say the only difference is the first I bits. So then we can, if we do that, then we can say dp2. So because I want to do this linearly, right? dp2 of bn of 0, obviously that is my dp of bn, right? There's no change. Which is my first factor, right? So dp2 of bn, let's say I plus 1, right? So if how do I move from here to here? So that is dp2 of bn of course I, right? So then I need to add, there's two possibilities. So if this is my bn and my, this bit is 0, then that's nothing I need to do, right? So otherwise is I take, my dp2. This basically means my bn and my I, 1 shift I, right? For that one, and the ith one, right? So the first and other, basically the first I of them are the same, right? So then we can calculate from use this one more iteration, right? So if we do this way, then I move from this to 2 to the power of m and n, right? So then I move it from 2 to the power of m times m, right? So I break this power into a linear, right, by doing one more dp this way. So the whole thing will be, remember I have previously have mm plus this, right? So then that is good enough for me to solve that. So this is actually pretty straightforward. It's basically a bitmask. You just need to figure out how to convert from here to here. The condition that everything in the front needs to be simpler than everything in the back is basically means this equation, right? Then the transformation from I to I plus 1 is pretty straightforward. It's all the preconditions times all the combinations of what will happen to Bn. Right? This combination is standard AP stats. The only difficulty is how do you further simplify this? So you further simplify this. This is actually a standard trick as well. You further simplify this to make another dp, which is instead of doing 2 to the power n, you go linearly down this way. So that's how you simplify the problem. So by doing that, you basically can solve this issue. So hopefully you have fun with this. Go back, please calculate, now put this into the code or review your AP stats if you are not familiar with how the selection, the combination works. Then next week, we will talk about problem number 3. Right? Then the US Open is basically this weekend, right? So we're a little bit behind, but hopefully you guys are having a good result over this coming weekend, basically this next week, right? So, and good luck for next weekend's competition. I'll talk to you after next weekend's competition.